Okay, so before we move on to dividing, and again, do you know everything you need to know about multiplying? No, but do you know more about multiplying than you knew yesterday? Yeah, okay, that was the goal. So I'm going to add one more thing that for some of you might make a whole lot of sense. For some of you, it might not make any sense at all. If it works for you, you can use it. If you're like, I don't like that, you can forget it, okay? I am going to show you kind of a trick in simplifying, but it only works when you are multiplying fractions. That's the only time it works, is when you have a multiplication of fractions problem. I am going to pull one of the problems from last night's homework, number 2. Okay, number 2, it says 8 times 4 eighths. Who can tell me what my next step should look like? And we talked about steps yesterday, and some of you guys went from there to an answer, and you made goofy mistakes because of that. Okay, take the extra time and write out the next step. Kendall.
Do I have to make them both a fraction?
Yeah, make them both a fraction. So this would be 8 over 1 times 4 over 8. Yesterday, I told you I'll teach you cross-reducing, but we're not ready for it yet. Okay? I'm going to show you a quick and easy way to reduce this problem specifically. You can reduce, Finley, diagonally. That means if there's something that goes into the numbers that are diagonal from each other, you can reduce them as if they were on top of each other. Okay? Just like we would reduce regular fractions. Why in this problem does that make this a lot easier? Look diagonal from each other. Look at 8 and 8. What goes into 8 and 8?
That's what my dad was trying to tell me.
Yeah, and I told you if your parents try and help you, tell them we're not there yet.
That's what I told him.
Yeah, because yesterday was day 1. So it is a possibility. I just wanted you guys to practice without it also.
That's what I did.
Did you have help?
No.
Then how did you know you could do that?
I mean, because 8 over 1 is equal to 8.
Okay. Well, anyway, so if it is the same number diagonally, they just really cancel each other out, because really I'm dividing by 8, dividing by 8. 8 divided by 8 is 1. 8 divided by 8 is 1 a second time. Can I have that, please?
Dominic gave this to people. Dominic gave it to people.
Okay. So if you have the same number diagonal from each other, just cross them out. They'll cancel each other out. Because really we're taking 4 times 8 and 1 times 8. So that means in the end we could divide them both by 8. Now that they're gone, we multiply straight across. 4 times, really that's a 1, is 4. What's 1 times 1? 1. And then we get a whole number of 4. Okay? It works with any time there's a multiplying fractions problem. I'm going to do one that's not a whole number. It did work on a lot of these problems. I'm going to do one from the back. That was 2/10 times 5/6. Now, I do require you to still show work. So we can cross-reduce on this one. So let's look diagonally this way at the 2 and the 6. Sophia, what is a number that 2 and 6 can both be reduced by?
12.
Reduced by, which means 2. So I'm going to show divide by 2, divide by 2. I'm going to mark it out. What's 2 divided by 2? 1. What's 6 divided by 2? 3. Now look diagonally the other way. Max, if I'm looking at 5 and 10, is there anything I can reduce both of those by? What? 5. So I can divide this by 5, divide this by 5. What's 5 divided by 5, Max? 1. So I'm replacing that with a 1. What's 10 divided by 5? Try again. 2. Good job. Now I have a lot simpler problem. What's left on the top, Lori? 1 times 1 is what? 1. What's 2 times 3? 6. This was number 4 from last night's homework on the back. Was the answer supposed to be 1/6? Yeah. Okay. This is more beneficial in the upper grades when your fraction numbers are larger. Okay. So if we have 12/50ths oops, not equals, times 40/48. Sadie, what can I cross reduce here?
12 and 40.
Okay, 12 and 48. What goes into both of those? 12, so I could divide them both by 12. 12 divided by 12 is 1. 48 divided by 12 is 4. What about diagonally the other way, Caden? Hey, Bryson, will you put all your books on the floor, please? If I'm looking at 50 and 40, what's a number that goes into 50 and 40?
5.
Higher. They both end in 0. You could do 5. 10. So I'm going to reduce them both by 10. So divide by 10. Divide by 10. So that would be 4 and 5. Now, some students like to rewrite their new fractions just so it's neater. Okay? Let's look at that fraction at the back. What do you notice about it, Maya? It can be reduced to the whole number what? 1. Now let's see if we don't notice that. If this reduces down to a whole number of 1, what's 1/5 times 1? 1/5. Okay, let's see if we just work it out from here. Should we get that same answer? Is 4/20 a good final? Nope, because it can be reduced by 4. So that would be 1/5. So could we have just reduced that to a 1 right there? Yeah. Okay? And again, I didn't want to show you that yesterday because I wanted you to learn the process, and that's not always available, but a lot of the times it is. Okay? So if you like that trick, use it. If you don't have to. You can do it just like you did last night's homework. Okay? Okay, moving on to today's, and I'm going to apologize for the way the worksheet printed. I stayed Thursday after you guys left, and that copier down at the end of the hallway, I tried to print this worksheet like 4 different times, and it just kept turning it and flipping it and doing crazy stuff to it. So finally I just this was the best one that I could get out of it. Okay? So who can tell me what are we going to be working on today? Brant? Dividing fractions, or dividing whole numbers by fractions, dividing fractions by whole numbers. Now, this is another thing that after testing we're going to come back to and do a lot of modeling. I'm going to do a couple models for these first one because they make sense. At the top, the only good thing about the crazy print job here, at the top of this there is some space for you to take notes. Okay, so whatever I write on the board, I want you to take notes at the top of this. Okay, so above where it says K5 Learning, like up above here, up here, there's room for you to take some notes. I am going to do it actually on my whiteboard just because I don't have that space up there, but you guys are doing them on this worksheet right above K5 Learning up in that margin. Okay, so we are dividing fractions. And remember, in a division problem, the dividend always represents a what? What does the dividend always represent in a division problem? Kendall? A total of some sort. Okay, so we are going to look at, well, we're just going to write a problem up at the top. Let's write the problem 2 divided by 1/3. You're writing this up at the top. 2 divided by 1/3. Soph, got that? So if I'm going to model this first one. That means I have 2 whole somethings. Okay, 2 whole somethings. We are going to make 2 whole sub sandwiches. There's 1, there's 2. 2 whole sub sandwiches. Now, remember, Finley, do you have a pencil? The divisor could be one of 2 things. Who remembers one of the things the divisor could represent? Parker? Not a remainder. Kendall? The number of groups or the size. Okay, the size of each piece or group or the number of each piece or group. If it's 1/3, do you think that can be a size or a number of pieces? size. You're going to cut this into thirds. If you cut 2 sub-sandwiches into thirds, let's do that. Let's do dotted lines for our cuts. Doesn't have to be perfect. So 1/3 is the size of the pieces. So our quotient in this one would represent the number of pieces. When I cut that into thirds, how many pieces of submarine sandwich do we now have, Lori?
6 pieces.
6 pieces. 2 divided by 1/3 is 6. Okay, because if I have 2 whole pieces, like if this happens a lot at like birthday parties. Okay, if your parents order cookies and there's not enough cookies for everyone, what do they typically do? Yeah, they divide them in parts, in smaller pieces. Everybody still gets a portion of a cookie, but do they all get one whole cookie? No, it makes more pieces, but the pieces are all smaller pieces. Okay, so when we divide whole numbers by fractions, that's what we're doing, is we had 2 whole sub-sandwiches, and now we have 6 sub-sandwiches, but is it 6 whole sub-sandwiches? No, it's 6 pieces that are all 1/3 of the original. Okay, and it's kind of a hard concept to understand. Now let's talk about the math behind it, because again, today we're doing a crash course. How could I take 2 divided by 1/3 and somehow get 6? Kendall?
2 times 3.
Okay, 2 times 3. Okay, she said multiply the whole number by the denominator. Okay, which in this one, that's true. What if the numerator's not a 1? Would that work? No, that wouldn't work if the numerator's not a 1. So here's the rule. And again, I told you today we're doing a crash course, so I'm just giving you the rule. So I want you to write rule up at the top. The rule is you do not divide fractions. We don't divide fractions. We create an equivalent problem. Okay, so we do not divide fractions. You multiply by the reciprocal. That might be an I. I think it's an O. Reciprocal. Reciprocal. So, the rule for dividing fractions is we don't divide fractions, we multiply by the reciprocal. Now, what word do we need to know what it means before we know what to do? Reciprocal. Does anybody know what a reciprocal is? Everybody say that, reciprocal. Dane, what is a reciprocal?
A fraction, but it's upside down.
Okay, he said an upside down fraction. So let's just give some examples. Let's write reciprocal examples. So Dane, if we're looking at the fraction 2/3, what is the reciprocal of 2/3? 3 halves, good job. Okay, so let's do several more. Let's say 2/7. Who thinks they know the reciprocal of 2/7? Sadie? 7 halves, good job. Okay, let's do 4/3. Who thinks they know the reciprocal of 4/3? Bryson?
3/4.
3/4, good job. Okay, so reciprocal is when you flip the fraction, so Dane was correct. Okay, if the numerator goes the denominator goes the numerator, you simply just flip it. Okay, now sometimes though, it'll be a whole number. What do you think is the reciprocal of 3? Bryce? Nope, because you have to flip. So Bryce, think about 3 as a fraction. What is 3 as a fraction?
It's
1/3. Good job. So 3 over 1. So the reciprocal would be 1/3. So what about 8? Brody, what do you think the reciprocal of 8 is? 1/8. Good job. Okay, so our reciprocal's hard. No, once you know what a reciprocal is, it's an easy concept. It's just you've never heard that word before. Okay, so now the rule says we do not divide fractions, we multiply by the reciprocal. I have an acronym to help you kind of remember what that means. Okay, I want you to, how much room? You still got plenty of room at the top? Somewhere where you have room, I want you to write capital K, underline it, keep, capital F, right, flip, capital C, change. Yes, so KFC is just an acronym, some letters that help you remember what to do, okay? So 6th graders, when I say how do we divide fractions, they say KFC, and I say what does that mean? And they say multiply by the reciprocal, okay? Because the mathematical rule is you multiply by the reciprocal, but that's still kind of confusing. So KFC kind of helps you process what to do. Okay, we're going to do one example up in the margin, and then we'll move to the problems down below. Nate, give me a whole number, any whole number. 10. Okay, let's work the problem. 10 divided by, Jude, give me a fraction. That's not a 1 on top. 3/4, okay. 10 divided by 3/4. Now, this is similar to multiplication that you first must have 2 fractions. Not whole numbers and fractions, not mixed numbers. You must have 2 fractions. So Haley, what do you think my next step should look like? Parker, will you put that away, please? 10 okay, so how do I turn 10 into a fraction? 10 over 1. Okay, so 10 over 1 divided by 3/4. Now that I have a fraction divided by a fraction, I'm ready to multiply by the reciprocal. Okay, what that means is we keep the first number the same. The first number never changes, it just drops down. So Parker, what am I going to drop down? What's my first number? 10 over 1, so my 10 over 1 is going to stay the same. Oops. So 10 over 1 drops down. Now, the rule says multiply by the reciprocal. What is the reciprocal of 3/4? 4/3. And it says we don't divide, we multiply by the reciprocal. So we're actually taking 10 over 1 times 4/3. But that's hard for people to process and remember. So here's where the KFC comes in. We kept the first number the same. We flipped the second fraction. And what did we change? Bryce, what did we change?
Both the whole number and the fraction.
Nope, that was our flip. We flipped that. Kendall? We changed the sign to multiplication. So keep the first fraction the same, flip the second, change the sign to multiplication. Now I have a multiplication problem. Do we know how to multiply fractions? Yeah. Max, how do I multiply fractions? Yeah, straight across. 10 times 4 is 40. Okay, keep going.
Sorry, came to school without glasses, and I keep a spare sitting here.
What else, Max?
I forget I can't read without them. When I leave in the morning, I don't need to read.
1 times 3 is what? 3. Good job. Caden, is that a good final answer? Why not? Because you have to simplify. What does that mean in this problem? How can I simplify that? Brody, help him out.
3 divided by 40.
Say it the other way.
40 divided by
40 divided by 3. Good job. So 40 divided by 3. Brady, how many times does 3 go into 4? Once. Good job. 1 times 3 is 3. Nate, how many times does 3 go into 10? 3 times. 3 times 3 is 9. I have 1 left over. Lori, what does all of that look like as a good final answer?
13 and 1/3.
Good job. 13 and 1/3. Now, why does that answer seem off? Why does that answer not seem correct, Parker?
Because the numerator of 1 was 4.
Okay. No. Dane?
Because when you divide, whatever you're dividing by, should always.
Yeah, not should. Usually, up until this point, if we started with 10 and we were dividing, our quotient would be under 10, right? So why is it higher than 10? And this is correct. Maya? Nope. Dane?
That's how many pieces there are.
It is a number of pieces, but why does that answer make sense? And this is what we have to practice, is our fraction number sense. Kendall?
Because we switched the fraction?
Nope. Let's think of, it's because of this fraction, 3/4. 10 divided by what equals 10? 1, okay? 10 divided by 1 equals 10. If this number is less than 10, my answer will be greater than 10. Because if I broke this into wholes, I would get 10 wholes. But my pieces are smaller than 1 whole, so I will have more than 10 when I'm done. Okay, and it's a confusing concept. We're going to keep working on it. Okay, let's move down to the problems, and I know half of them are cut off. Let's go to 6 divided by 1/2. Let me pull this up real quick. Give me just a second. 6 divided by 1/2. Maybe. It's going to pull up. Come on. There's a problem with the file. That's not it, is it? Oh, yeah, it is. It's just over here. Okay, so we are over on this side. 6 divided by 1/2. Who thinks they know what my next step should look like? Lori.
Make the 6 into a fraction.
Yep, so, and I don't want you to write it over there. Yesterday, did I change the original problem? Nope, always rewrite. Some of you did a good job of that last night, some of you did not. 6 divided by 1/2. Now I have, what is my rule for dividing fractions, Bryce? 4 words. Brant, sorry. Who can give me those 4 words? Finley?
Don't divide.
Well, that's not the rule. That's just our, so what is our rule?
Multiply by the reciprocal.
Multiply by the reciprocal. What trick did I teach you to help you remember how to do that, Lori?
Keep flip change.
Okay, so keep the first. Keep the first. So I'm just going to work across because that's where our lines are. Keep the first. What does the F stand for, Bryson?
The F.
In keep the first.
Oh. Keep flip.
What do I have to flip?
The 1/2.
The 1/2, what's it going to become?
2, 1.
2 over 1. And what does the C stand for, Dominic? Keep, flip, change. What am I changing? I already flipped. Sadie?
You're changing the division sign to.
Changing the division sign to multiplication. Now I have a multiplication problem. How do I multiply 2 fractions, Sophia?
You turn the 3 into.
How do I multiply fractions? Back to last night.
You 6 times.
Yeah, go straight across. 6 times 2 is what? Yep. What's 1 times 1?
1.
And then simplify. 12 over 1 reduces to? 12. Let's do number 4. Sophie, help me with my first step. What do I have to do first to divide fractions?
You have to change 3 into a fraction.
Yeah, I have to have 2 fractions first. So we'll start with making this a 3 over 1 divided by 2/4. And notice, am I changing or flipping anything in that step? No, do one thing at a time. It'll prevent you from making goofy mistakes. Reese, now that I have 2 fractions in a division problem, how do I divide fractions? What's my rule? 4 words. Dane, help her out. What's more 4 words? Multiply by the reciprocal. Reese, what does that mean?
You have to flip the 2 over 4.
Okay, so I keep the first. You are correct. I flip the 2 over 4. What else? Go ahead, Reese. I change the sign to multiplication. And now that we have multiplication problems, if I could cross reduce, I could do it in this step because I have a multiplication problem. Okay, this one I cannot cross reduce anything. Lori, how do I multiply 2 fractions?
You multiply the numerator and the denominator.
Yep, so 3 times 4 is 12. 1 times 2 is 2. Turn off our math brain, turn on our common sense brain. Jude, what's 12 divided by 2? 6. There we go. Is dividing fractions super confusing? No, it's really just one extra step in addition to multiply. Look over on the next set of problems, over on the right. Give me just a second to get it pulled up. What's different about those problems, Nate?
One is, you can divide 1.
What's the difference between the ones on the left side that we were just working and the ones just to the right of them? Yeah, they flipped where the whole number was. So this one, I only have half of a, well, this one's 2/4, which is half. I only have half of a sub sandwich, and I'm cutting that half into 3 equal parts. So my answer is going to be the size of those pieces. So let's just think. If there's only half of a sub sandwich here, okay, here's half of my sub sandwich. You got to look at my hands. And I say Brody, Sophie, and Bryce are sharing equally this half of a sub sandwich for lunch. Are they still going to be hungry after lunch?
Probably.
Why?
Because
Yeah, because the pieces are not going to be that big. Do we all agree with that? So that's what we're answering, is the size that each of them will get. We're still going to follow our same process. So number 1, I have to have a fraction divided by a fraction. So Maya, what's my next step going to look like? Yeah, so I have 2 over 4 divided by 3 over 1. Next step, Jude. What's my rule for dividing fractions? That's my trick. What's my rule? Multiply by the reciprocal, which he says to remember that. You can keep, flip, change. Tell me what that means. Keep what, flip what, change what? And then change. Good job. Keep the first number the same, flip the second or find the reciprocal of it, change the sign to multiplication. Now we have a multiplication problem. What's 2 times 1? 4 times 3? Can 2 over 12 be reduced? What can we reduce them both by? 2. I'm just going to come up. So that would reduce down to 1/6. Does it make sense if I had half of a sub sandwich and I split it between Bryce, Sophie, and Brody, that each of them would get 1/6 of a whole sandwich? Yes. Okay. Is that very much? No, and you guys decided up front that you wouldn't want to be sharing half of a sandwich with 3 people because you wouldn't be getting very much of that sandwich. Okay, I want you to try 3 and 5 real quick on your own. If you need extra room to work, you can use the space down at the bottom. So I want you to try 3 and 5. Shh. Brady, are you working? 3 and 5, Brady. Once you work them, look up. If you missed one and can't figure out what you did wrong, raise your hand and I can come help you. If you've already finished them and checked them, I want you to flip your paper over to the back side. Because it's this one. So here's our division problem. So keep, flip, change.
Oh, so it goes in that one. I thought you'd flip
The first one you always keep the same. You're changing the sign, flipping the second. Okay, any other questions about those two? Okay, why is the back side actually a little bit easier? They're already fractions. Yeah, so our first step is kind of already done for us. I already have a fraction divided by a fraction. Let me find it real quick. That's multiply. I might just pull it up on whiteboard. Okay, I'll just pull it up here. Brody, can you read me the first question, please? 1/4 divided by 9/10. Parker, what's my next step going to look like? So here's what yours looks like. So how do we divide fractions? 4 words. Reese, tell him the 4 words. Good job. Multiply by the reciprocal. Haley, what can I do to help me remember that? What 3? KFC? What does the K stand for? Keep the first the same. What does the F stand for, Haley? Flip. What am I flipping? The second one. That's where that word reciprocal comes in. And what am I changing? Yeah, the division sign to a multiplication sign. Now, this is one where I can multiply straight across and reduce. Could I cross reduce on this one? Look diagonally from each other. Dominic, could I cross reduce something here? What? So it's just like reducing a regular fraction, but you're just looking diagonal. So is there anything that goes into 1 and 9 that would make it smaller? Nope. Is there anything that goes into 4 and 10? They're even, so what goes into them? 2. So let's cross reduce this one by 2. So show divide by 2, divide by 2. What's 4 divided by 2? 2. What's 10 divided by 2? 5. Now, just to keep this neat, I'm going to rewrite my new fraction. I really have 1/2 times 5/9. Okay, if you write nice and neat, you can probably just not do that step. But I know you guys.
I don't like that step.
Yeah, if you don't like that step, you don't have to do it. Okay? Because I'll work it the other way in just a second after we get an answer. What's 5 times 1? 5. What's 2 times 9? 18. Now, Bryce said he doesn't like that step, and that's perfectly okay. So from here, he would have taken 1 times 10 and gotten 10, 4 times 9 and gotten 36, and then what would you have had to do, Bryce? Simplify. If we divide those both by 2 now, we would still get the same answer. So that is 100% okay. Okay, so yeah, if you don't like the cross-reducing step, you can still get to that same answer. Okay, are you experts on dividing fractions? No, but are you a lot better at it now than you were 30 minutes ago? Yes. On this side, listen carefully. On this side that you're looking at, I want you to circle any 3 problems. Any 3 problems.
We don't have to do cross.
You do not have to cross-reduce. Nope. Okay, so you're circling 3 problems. Okay, then flip it over to the front side. There's really 3 columns. Do you guys kind of see 3 columns? Okay, in the far left column, circle 3 problems. We did 2 and 4 together. I want you to choose 3 from that column. In the far left column. Okay, and then go to the far right column, which we don't have any done in. The far right column, choose 3. Nope, we did those in the middle column. We're on the far left and the far right. So there's problems here, here, and here. So we're not doing any more from that column. So you're choosing 3 from this column, 3 from this column, and 3 on the back. So how many problems are you doing altogether? 9. Any questions on what your homework is? Because no one's been walking in it. Okay, go ahead and get started.